Dear students, today I am going to discuss machine tools. So in that this comes under module 5. So one of the machine tool today I am going to discuss is lathe. Okay. So before moving to that, first of all we should know what is tool. A tool is an instrument or a piece of equipment that we hold in our hands and use to do a particular kind of work. So what is first of all tool? So we use the tools to produce some product, like we get the raw materials. Okay, so then if I want to produce some product, I need to remove some extra materials. Okay, if I remove the extra materials from that raw material, so I'm going to get the product. So like this will be done in the industries. Okay, so tool is an instrument or a piece of an equipment that we hold in our hands and use to do a particular kind of work. Okay, so examples: hammers, saw, screwdriver, chisel, lathe, drilling machine, milling machine, grinding machine, etc. Okay, so these are the examples for tool. Okay, so tools are mainly there are two types. One is hand tool and the one more is machine tool. Hand tool is nothing but the tools which we used in our hands. Okay, so to perform any kind of operation is called hand tool. So whatever the tools we are going to use in our hand, we call it as hand tools. Okay, so now what is machine tool then? So machine tool, which is defined as, okay, so it is defined as a power driven machine to produce a product by removing the excess material using the cutting tool. Machine tool is nothing but that tool is driven with the help of machine or motor, with the help of motor. So we use that as machine tool. Okay, so examples: lathe, drilling machine, milling machine, grinding machine, and all. Okay, so for your syllabus you are having lathe and milling machine, so this we are going to study lathe further. So hope you have seen the lathe in an workshops and drilling machine. Okay, so here what is lathe? Lathe, it is defined as a machine tool where a hard cutting tool is fed against the rotating workpiece to remove the excess material. So this is the definition of lathe. So it is defined as a machine tool where a hard cutting tool is fed against the rotating workpiece to remove the excess material. So why we want to remove excess material? To get the final product, we need to remove excess material in that raw material. So finally, so we're going to get the final product. So now, what is lathe? Lathe is a machine tool. Why it is called as machine tool? It is driven by a motor, or it is a power driven machine. So that's why it is called as machine tool. So here what happens? The hard cutting tool. So if you want to remove any material from the raw material, okay, so the cutting tool should be harder than the material what we are going to cut. Then only we can cut the material. If not, tool will break. If the tool is softer than the workpiece, then tool will break. No cutting of the raw material takes place. Okay, so here one more thing we need to consider is the workpiece will be rotating. In lathe what happens? Workpiece will be continuously rotating and we are going to feed the tool against the rotary workpiece. So by this way we can perform the lathe operations. Okay, next, moving to principle of working of lathe. So what is the principle? On what principle this lathe is works? Okay, so basically this is workpiece, which you can see here is workpiece, and this one we call it as check. Okay, so I will explain what is the check and all later. And this is workpiece and this is tool, and we can give the two types of movement of tool. One is horizontal, one is this one vertical movement. Okay, so here what happens in this principle of working is, so I already told the workpiece is fixed to this check. So okay, the workpiece is fixed to check. Then if you switch on that, this workpiece starts to rotate. The workpiece starts to rotate and the cutting tool is firmly fixed, and we feed this cutting tool against rotating workpiece. Then the unwanted material will be removed from the workpiece and we are going to get the final product. Okay, so this is the principle of working of lathe. Okay, now let's see what are the various parts in the lathe and their functions. Okay, so the major parts in the lathe are: one is bed, second one is headstock, third one is tailstock, fourth one is lead screw, and the fifth one is feed rod, sixth one is carriage assembly. So carriage assembly consists of saddle, cross slide, compound rest, tool post, apron. So combining all these five, we call it as this carriage assembly. Okay, now let us see the diagram of the lathe. So this is the diagram of your lathe. So you can see here, lathe consists of, I told like, so first one is this supporting member, we call it as bed. So this we call it as bed, and this is headstock, and this one is tailstock, and this completely we call it as carriage assembly. Okay, carriage assembly, and this is feed rod where carriage assembly moves, and this is lead screw. I will explain the functions of one by one now. Okay, so this is actually a bed. So you can see here, so this is a bed on which all these parts are mounted. Okay, so lathe bed basically made up of grey cast iron. It is made up of grey cast iron, and at the top of the bed there are two sets of machined guided, inner and outer. Okay, the headstock and tailstocks are mounted on inner guideways, and carriage assembly is an outer guideways. So there are two types of guideways, one is inner and one is outer guideways. So inner guideways, there is a mounting of headstock and tailstock, and in outer guideways, so this carriage assembly is mounted. Okay, now what is headstock? So it is mounted on the left of the lathe over the guideways. Okay, so this is mounted at the left hand side of the lathe. Okay, so it comprises of main drive connected to step cone pulley and back gear for different speeds. So the main drive, as I told, the motor which is connected to this check through pulleys. Okay, so stepped pulley. What is stepped pulley means? See, for different operations that I am going to discuss later, we have to reduce the speed of the check, okay, or rotating member. So then we can able to control the speed of that workpiece. Okay, so for that we are going to use different kinds of steps in a pulley, okay, to maintain the speeds. So next, coming to tailstock. So it is a movable part mounted at the right end of the lathe bed. So movable means we can move this like in the horizontal manner. Okay, it carries the dead center. And the important functions of this tailstock is it will support the other end of the workpiece. If the workpiece is long, so we need to fix the other end of the workpiece, and also it holds tools like drill bit, so we can fix the drill bit here, or reamers, tapes, etc. to perform drilling, reaming and tapping operations. So this is the function of tailstock. Next, moving to one of the important part is that is feed rod. So feed rod is a long rod with a slot along the length and is mounted in front of the lathe. So it is mounted in front of the lathe, okay, and which is used to move the carriage assembly. So this carriage complete assembly is fixed on this feed rod. Okay, so by rotating this hand wheel, we can move this carriage assembly in the horizontal manner. Okay. So next, lead screw. So it is a long screw with square threads on which is mounted in front along with feed rod. So which is having a square threads. So in front of feed rod it is mounted. So this is used for automatic movement of the carriage assembly during thread cutting operation. So this lead screw is used only during the thread cutting operation. Okay, so if we engage this lead screw, the carriage assembly moves automatically to get the thread cutting, okay, threads on the workpiece. Next, coming to the important part here is carriage assembly. So as I already told, carriage assembly consists of different parts. One is saddle. You can see here saddle. It is an this one. So this is an H-shaped casting sliding over the guideways and supports cross slide, compound rest and tool post. You can see here. So this saddle, which is supported by this compound rest, cross slide and tool post. These three parts mounted on the saddle. Next. So next part is cross slide. Cross slide is mounted on the saddle. It enables the cutting tool to move perpendicular to the lathe axis. So what we can do by using this cross slide, we can move the cutting tool in a perpendicular manner, perpendicular to lathe axis. To give the depth of cut, we are going to use this cross slide. If you rotate this means it will move perpendicular to lathe axis. Okay, so the tool will move perpendicular to lathe axis. Next part is compound rest. Compound rest is mounted over the cross slide. Okay, so and it supports tool post. This has a circular base. So compound rest has a circular base where we can rotate, this one and give some particular angle. So if you want to obtain taper, so we need to rotate this one and to feed the tool in a certain angle. Okay, so for this purpose we are going to use this compound rest. Next is over the compound rest we are having the tool post. Okay, so the tool post function is which holds the different types of tools. Okay, we can fix the tools here on the tool post. Number of tools like 2, 3, 4 tools we can fix it on the tool post. Okay, so for different operation we can rotate this one and we use the particular tool to perform the operations. So this is about carriage assembly. And if you see here there is a tray. So tray is placed here to collect the unwanted material which is removed from the workpiece in the form of chips. So all those material going and collecting here, later it will be removed. Okay, so this is about lathe. Next, let us see what are the different operations we can perform using the lathe. So 6 different operations we can perform using the lathe. One is turning, next is facing, next knurling, thread cutting, drilling and taper turning. So these are the different operations we can perform using the lathe. Let's see one by one. Okay, now turning. So what is turning? So turning is also called as cylindrical turning. Okay, in this operation we remove the excess material from the workpiece to produce a cylindrical part with circular cross section. So this operation is used to produce the cylindrical part from the workpiece. You can see here. So this is a chuck which is at the edge center. So this is workpiece which is fixed to chuck by rotating this jaw. So what happens, the workpiece will be fixed here and we are going to feed the tool against the rotating workpiece. So what happens in this operation, we can produce a cylindrical member. So here workpiece will be rotating at a higher speed, then tool is fed against the rotating workpiece. So we are going to get the cylindrical surface on the workpiece. Okay, so this is the turning operation. Next operation is facing. So facing is nothing but it is the operation to produce flat surface flat surface on the one end of the workpiece. So what we are going to do here is, we can, if we want a flat surface at one end of the workpiece, so we can obtain the flat surface. Again here, one end of the workpiece is fixed to this check, and tool is fed perpendicular to this lathe axis. Okay, so if you were perpendicular to this lathe axis, so we are going to remove the excess material and to get the flat surface at one end of the workpiece. So this is called as facing operation. Or if we want to reduce the length of the workpiece, so we will go for facing operation. Okay, so next operation is knurling. So what is knurling? What is knurling? So knurling is an operation which is carried out by the special tool called, this is knurling tool. Knurling tool. Knurling operation is performed to obtain the rough surface on the workpiece. You can see here, we can get the various patterns on the workpiece, on cylindrical workpiece, like means it may be all these three horizontal, inclination and this hatchet portion. So we're going to get this rough surface on the workpiece. So for this purpose we're going to use knurling. So why we want this rough surface? Maybe you have seen this on the screw gauge. So the, like that barrel of that micrometer or screw gauge is, you can feel there is a rough surface on that. So why means to grip that surface or to grip that barrel. So we're going to obtain the impression which is that of exactly the tool which are going to use. Okay, so this is hard steel roller, that is the tool we're going to press against the rotating workpiece. So here the speed of the workpiece will be very low. Okay, so like in thread cutting and facing operation the speed will be very high, but here the speed of the workpiece, rotating workpiece, is low, and the other end of the workpiece also supported with the help of tailstock or dead center. We call it as dead center. Why we call it as dead center? Because so this center will not rotate, this just fixes the or holds the other end of the workpiece firmly. Okay, so this is the knurling operation, this is the knurling tool, and these are the different patterns we can get it by using the different types of tools. Next one is thread cutting operation. So what is thread cutting? So before this, let us see what is thread. Thread is nothing but a helical grooves formed on a cylindrical surface of the workpiece. We can obtain in the various forms a groove which is, see, cylindrical surface will be there like this. So we are going to get the threads on the surface of the cylindrical surface. So that we call it as threads. So the shape of the threads will may V thread or square thread. So there are two types of threads we can obtain here is, that is V thread. V means this one. One is like square threads. So we're going to get it the different types of threads here. So thread cutting operation is performed on the lathe by using the tool whose profile will be same as that of the thread profile. So whatever the tool we are going to use here is, if you want the V thread, so we are going to use the V thread tool, and if I want square thread, we are going to use the square thread tool. So again here, the one end of the workpiece is fixed to check and the other end is connected to dead center to fix the or to hold the workpiece firmly at the other end. So here we are going to apply some pressure. So if you apply some pressure, what happens? The cutting will be taking place. See, during thread cutting operation, the tool movement will be automatic. So here we don't feed the tool manually like we have done in the knurling, facing and thread cutting. Here the tool is fed automatic. So with the help of lead screw, Yeah, we have seen here, no? Yeah, with the help of lead screw, we engage this carriage automatic. So what happens during thread cutting operation? The lead screw will be engaged, then the movement of the carriage takes place automatically. Why we want to go for automation means during manual feed there is a chances of moving the carriage at different speeds, then the thread profile will vary. If the thread profile varies, then we are not able to tight it or bolt with the nut. Okay, so thread profile should be even. So for this purpose, this thread cutting operation will be automated, okay, to avoid any damage to that thread surface. So thread cutting will not be done in a single pass. So thread cutting will be carried out in different passes. It will be carried out in many passes with incremental depth. So we cannot get the at a single pass we cannot get the complete thread. So what we need to do, we need to remove the material on the surface step by step. Okay, with the first during the first process small incremental depth, and the next cycle some more incremental depth, then finally we are going to get the threads on the external surface. Okay, so again we are having the two types of thread, one is external thread and internal thread. In this lathe we are going to get the external thread. Okay, so where we can see external thread, if you have seen the bolt, okay, so on the bolt we are having the external thread. Where we can see internal thread, on nut is having internal threads. Okay, next operation is again in thread cutting operation, the workpiece movement will be very low. The rotation of workpiece will be very low during thread cutting operation. Unlike turning and facing, here the thread cutting operation is low, even in knurling operation. Next, moving to drilling. So what is drilling? Drilling is an operation to produce a cylindrical hole on the workpiece. We are going to produce the cylindrical hole on the workpiece. Usually drilling operation is carried out using drilling machine, but if we don't have drilling machine, even we can do it in the lathe. So here the difference between drilling machine and this lathe is, so in drilling machine the tool will be rotating, workpiece will be stationary, but in this lathe the workpiece will rotate and the drill bit that is fixed to tailstock. Okay, so here the stationary drill bit or tool will be fixed to tailstock, then the workpiece will revolving. So during this operation we are going to obtain the cylindrical surface on this workpiece. Okay, so the workpiece is fixed to check, which is at live center, and this will rotates, and the drill bit is stationary. We are going to feed this tailstock against the rotating workpiece. So why we have to move the tailstock? So tailstock consists of what? This drill bit. By rotating this hand wheel, we can give the feed or depth of this tool to obtain the cylindrical surface. Next, let us see taper turning. So what is taper? First of all, it is an operation to produce conical surface. Conical means one end of the diameter is larger and the other end is smaller. So this we call it as taper surface. To obtain the conical surface on the workpiece, this operation can be performed. So there are many ways or methods to obtain the taper turning. In this we are having like compound side spooling method, tailstock offset method, taper turning attachment by using form tool. So various methods where you can get the taper. So you can see here, so this is the taper section of the workpiece obtained. So for your syllabus, two methods are there. One is swiveling the compound rest, one more is tailstock offset method. Okay, let us see here. First one is taper turning by filling the compound rest. So as I already told when I explained the compound rest, so compound rest is a circular member which is having certain angles printed on that. Okay, so we can give the rotation to that compound rest, then the tool will rotate. Okay, so tool will rotate. You can see here, you can see there is a 2 alpha. If I want to calculate this angle, so we're having the formula like tan alpha is equal to d minus d by 2l. What is d? Capital D, that is larger diameter of the taper, and small d is the smaller diameter of that taper, and length is L is total length of the taper. If we use this one, we will get this alpha, and with the help of this alpha we can rotate this compound rest and give an angle, then the feeding will be taken place. So by doing this one, what happens, workpiece will be rotating, and if you feed this tool or inclined tool against the rotating workpiece, we are going to get the taper. Okay, so by this way we can obtain the taper in the workpiece. So next method is, that is by offsetting the tailstock. So here the carriage or the tool movement will be parallel to the lathe axis, but what happens here, the workpiece will be inclined. How we can do this one? So by moving the tailstock to certain angle, then fix the workpiece. Here tailstock body is shifted for small distance. Okay, so this makes the workpiece shifted at one end, and hence there will be an inclination with respect to the lathe axis. Okay, the tool is moved parallel to the lathe axis. Okay, so then, but due to inclination in the workpiece, the taper angle will be obtained. Okay, so this is by offsetting the tailstock, we are going to get the taper in the lathe. So this is about the operations which you perform using lathe.